Hi, this is Maggie. In this video we're going to talk about the distance formula. The distance formula is a formula that you can use to measure the distance between two objects in your game using their XY coordinates. This image is figure 9.4 from the text. Imagine that we have an object at coordinate 5,3 and another object at coordinate 13,9. To make this interesting, let's pretend that the object at 13,9 is an artificially intelligent robot programmed to collect batteries. And let's pretend that the object at 5,3 is a battery. These images are from the site Public Domain Vectors. We can compute that the battery is 8 pixels away from the robot in the x-coordinate because 13 minus 5 is 8. And we can compute that the battery is 6 pixels away from the robot in the y-coordinate because 9 minus 3 is 6. Now imagine that there's another battery located at 14,1. We can compute that the second battery is 1 pixel away in the x-coordinate because 14 minus 13 is 1, and we can compute that the second battery is 8 pixels away in the y-coordinate because 9 minus 1 is 8. But which battery is closest? If our robot is programmed to always collect the closest battery, which one does it collect? The distance formula will answer the question for us and for our robot. In figure 9.4, the x and y distances are drawn as lines connecting the robot and the battery, or the 2 points, and a third line is drawn connecting them directly. Together, the 3 lines form a right triangle. That makes the distance between the points the hypotenuse of that triangle. So we can use the Pythagorean theorem to find the length of the hypotenuse, or distance between the points. We already know how to calculate the sides of the triangle. We subtract one x-coordinate from the other, and we subtract one y-coordinate from the other. It doesn't matter in what order we subtract the coordinates. The difference between 13 and 14 is 1. If we subtract 13 from 14, we get positive 1. And if we subtract 14 from 13, we get negative 1. But we're going to square the difference in the Pythagorean theorem, which will always yield a positive result. To find the distance, then, we take the difference between the x-coordinates, the difference between the y-coordinates, square those differences, and add them together, and then take the square root. When we do that for our robot and battery problem, the first battery is 10 pixels away, as shown in the original figure. 6 squared plus 8 squared is 100, or 10 squared. When we apply the distance formula to the other battery, we get 1 squared plus 8 squared, which is 65, and the square root of 65 is a little bit more than 8. So the second battery is closer, and that is the one our robot should collect. Let's write a program to illustrate this. We will begin from our template, and we will rename it as batterycollector.py. And I will create surface objects for our robot and our battery image and load them in. OK. And I'm going to have one robot and two batteries with random XY coordinates, which means I will need to load in the random library and annotate and randomly generate some coordinates. Now, there's a better way to do this. I could store the coordinates in a list, for example, but I want to keep the syntax as simple as possible and focus on the distance formula. I'm going to randomly generate coordinates between 0 and the width of the window minus the width of the robot or battery, and between 0 and the height of the window minus the height of the robot or battery, so that they appear fully within the window. I'm also going to fill the background with white because the batteries won't show up very well against a black background. At the bottom of the game, I'll blit my robot and I'll blit the battery surface twice using the different coordinates each time. Remember, we're copying the image when we blit it, so I don't need two separate surface objects representing batteries. I can copy that one surface as many times as I need to the screen. Okay, now let's run that a few times and see how it looks. And it looks fine. They're randomly appearing in different locations. Now let's set up a counter for 2 seconds. So I'll annotate and initialize to 0. And then I'll increment each time through the game loop. And when it reaches 60, which will be at 2 seconds, I'll have the robot move to the closest battery. So I'll use the distance formula to calculate each distance. I'll annotate two new variables, distance 1 and distance 2. And I'll calculate them using the distance formula. I will need to import math so that I can use math.square root. And it will be robot x minus battery 1x squared plus robot y minus battery 1y squared, and I'll put all of that inside math.square root, and that is assigned to distance 1. Now copy that and use battery 2x and battery 2y and assign to distance 2. Now I will compare distance 1 and distance 2, and I will set the robots x and y to the closer battery. What happens if the two distances are equal? Okay, you might notice that I did not take the size of these surface objects into account. A better way to do this would be to calculate the middle of each of these surface objects and calculate the distance from the middle of the robot to the middle of the battery. But I just used the point that I blit them to again to keep this code as simple as possible and to keep the focus on the distance formula. So I will be setting the robots x and y to new coordinates, the coordinates of one of the batteries, at 2 seconds. So when the robot is blitted to the screen that time through the loop, it will be blitted to its new location. What would be fun is if it repeated. So I'll put another test for 4 seconds. Counter equal to 120. And I'll reset the locations of all 3 objects and set the counter back to 0, and it will happen again. Let's run that, and we'll watch it for a while. Does the robot seem to be moving to the closest battery? Remember, the distance is being calculated based on the top left of each image. Okay, so that's the distance formula. It can be very useful to know the distance between 2 points on the screen, and the distance formula allows us an easy way to calculate that. Try rewriting this program from your template, doing as much as you can without looking at this code. If you're feeling ambitious, calculate the distance from the middle of the robot and battery surface objects, and put the batteries in a list and write loops to generate the battery locations and blit them to the screen. Once the values are in lists, you can easily add more batteries simply by changing the size of the lists. When you can rewrite this program and maybe write some of the enhancements, you're ready to move on.